Okay, let's do one more example of absolute value inequalities. Okay, so when you see something like this, I'm gonna, step one, ignore the inequality sign. You're gonna get 2 absolute value of x is equals to absolute value of x x plus 3. Now this is interesting because we haven't come across something like this before, but it doesn't really matter because I still can dissect into 2 cases. One is 2 times by x is equals to x plus 3 for both functions are positive, or it can be 2 times by negative x, which is negative 2x equals to x plus 3. Now, question, do I have to consider when both functions are negative? Well, the answer is no, because if both functions are negative, negative here and a negative here will cancel out to give me the same scenario as this. Okay, if you think about transformations, if you put a negative in front of the entire function, it is reflection on the x-axis. So their point of intersection, if they do intersect, will be on the same x coordinate. If that doesn't make sense to you at this point in time, don't worry about it. Just know that if both parts of the absolute value, so if both the left-hand side is negative and the right-hand side is negative, they sort of like is the same as positive equals positive. Yeah. All right, same thing happens if the scenario 2x is positive and the right-hand side negative x plus 3, so the right-hand side is negative, you get this. Well, this is actually the same as this. Okay, these two are actually the same. Same here and same here. So I don't have to consider this. You don't have to worry about these 2 cases. So you don't worry about these 2 cases. All right. Now, just looking at these 2 cases, now the first 2 cases, when one side is positive and when it's negative, all right? So this means that I've got x is equals to 3, and over here I've got negative 3x equals positive 3x equals to negative 1. So again, I'm going to draw my number line. I've got 2 critical values, negative 3 and 1. Dissects into 3 regions. The first region is here, second region is here, third region is here. This one, I'm going to pick x equals negative 10 just because I like 10. This is 0. This is positive 10. Let's do that. Okay. So to test region number 1, if x equals to negative 10, 2 times by negative 10's absolute value, okay, is a greater than negative 10 plus 3, the absolute value of that. Absolute value of 10 is positive 10, so on the left hand side is 20. So is 20 greater than the absolute value of negative 10 plus 3 is negative 7. Is 20 greater than 7? Yep, it is, so I do want that. For the second part, if x is equals to 0, then 2 times by 0 is 0. Okay, absolute value of 0 is 0. Is it greater than, whoops, hang on. Is it greater than 0 plus 3 is absolute value of 3 is 3. So is 0 greater than 3? Absolutely not. So I don't want this part. Testing the third region, if you look at 10, if x is equals to 10, I got 2 times by 10, so absolute value of 10 is 10, is it greater than absolute value of 10 plus 3. Is that true? Well, that means it's 20 greater than 13. Yep, it is true, so I do want this. In another word, for this particular inequality, I want all the x's on the left-hand side of negative 1 and all the x's on the right-hand side of, oh, no, not 10. Got confused with my critical value on the right-hand side of 3. Okay, so what's your answer to this? This is x is less than negative 1 and x is greater than 3. That is the final answer.